Okay, folks, welcome to lesson 16. Here, what we're trying to do is we're trying to find the mean of a population only having a sample. So we're calling this confidence intervals for a population mean where we know the standard deviation of the population. Normally we don't, but some cases we do. So this is the easiest lesson of the confidence intervals. And let's just start with the problem, okay? How about this problem? Suppose that 25 Foothill College students are randomly selected. The mean age for the sample is 30.4. The population standard deviation has been pretty consistent at 15. Construct a 95% confidence interval for the true mean of the college students. So what we're doing is we want to be 95% sure, given a little range, what the age of the population is. Well, the sample was 30.4. What if, to be 95% sure, it was 2 years? So what do we say, 28.4 to 32.4? This is the idea of this lesson, and it has tremendous implications in business, marketing, government, a lot of things. So let's see. Okay, that was our question. We'll come back to that later. Now, don't forget your tasks. We've been through this before, but the little introduction, the lecture, the example, the exercises, and then the quiz. I'll try to end up with a little quiz advice for you, so maybe that can help you. Also, don't forget we're going to keep on using this requirement to get into the lesson. All right, let's look at some note taking, some boiled down concepts of the unit or this lesson that are very, very important. So again, what we're doing is we're really talking about inferential statistics. We're trying to infer from a sample what's going on in the population. We're going to use this idea of margin of error. We're going to get some type of a guess about the population, and then we want to know how close we are from the actual value of the population, and that is very, very helpful. Now this lesson is about finding the mean. We're going to get a estimate, okay? We're going to try to get a range for the true population value, and we're going to do that by using our point estimate and a margin of error, plus or minus, like that previous example I gave you. Don't ask me why we have this repeated here, but that's okay. Now, let's talk about the idea of a confidence interval. A confidence interval. So we're going to take a point estimate, and then we're going to go plus or minus some range of value. Here's my example. I'm trying to estimate the population mean. It's between 64.76, and that should be 72.4, okay? Let's say this is the age of the most recent 1,000 people that joined AARP, okay? Now I could write that this way using parentheses, and it means the same thing. However, one thing that is crucial in statistics is being able to explain it to Joe Blow on the street. So what that would mean is, given what I just mentioned, how would I word that? I would say the average age of the individual that recently joined AARP is between 64, let's just say 65 and 72 years of age. That's what I would do, okay? So I would word it that way. We need to be able to interpret for our own benefit and for the benefit of who we're doing our study for. All right, let's move over here to the right. So what we're doing is we're trying to find some sort of confidence level. And obviously, we have a sample. This is representing a sample of our population, okay? And our sample, we don't really know if the mean of the sample is going to be the This is a point estimate. Going to be the true mean because we only have a sample. So what we understand that the mean is somewhere in the range here, to the right and to the left. It's somewhere there. Now, if we want to make sure that we include the actual population mean, we could just go wider, okay? Wider is better. Sometimes wider is not better. And so what we're going to do in order to help us with this, we're going to have to find a critical value. The critical value is related to the confidence that we're wanting to be sure that we have included the population mean. You know, that's the gist of it right there. And you can actually find these values on your calculator, okay? But just remember, the more confident you are, the more confident, then the wider or more the margin of error will be. So hopefully that makes sense. All right, let's see. There's a couple assumptions that we need to keep in mind. First assumption is that we are using a simple random sample. That is crucial. Another assumption with lesson 16 is that the sample is greater than 30, or that we know the population is normally distributed. That is a very important set of assumptions, so just keep that in mind. Now, what are some other things I need to know? Well, when we're working problems, we need to remember these steps. So find out point estimate, find out critical value, find our standard error of the mean, and then use that to find the margin of error. And then write an expression. That's what I would do. Write this expression. You could use your calculator to figure that out and then interpret it, okay? Whether you have to do it with the test or not, whether I'm going to give it to you as an extra credit assignment, it is very important that we get out of this class knowing how to interpret. That's going to be extremely important for Unit 4. All right, a couple other things I wanted to point out here is that when you're using the calculator, you are going to be asked, are you going to use a data sample or are you going to use statistics? Most of the time we will do our work from the statistics. So if I have an opportunity, I'll share that with you in this overview. And here is the item that we're going to paste to the home screen. And again, it's Z interval, standard deviation, mean, N, and your confidence level. Now, there is a little twist here, just like there was in the last lesson. Sometimes a research person would like to do a study, but really what they know, now that they know a lot of statistics, they want to find N, the number of people I need to be researching. How many people are in my sample? And so just like the last lesson, there's a formula we could use. And in this lesson, here's what N is. It is the critical value times the standard deviation over the margin of error, and that whole thing squared, okay? And remember, if we get any kind of decimal answer, we round up to make sure we include that. Folks, that is the gist of the notes in this particular section. All right, a couple things we need to point out, the terminology. Point estimate, make sure you know that. Confidence interval, okay? That's that left and right, okay? The values, 65 years age to 72 years age. Confidence level, okay? Make sure we understand that, the confidence level, okay? And normally it's a percentage. We use 90, 95, 99. Those would be good values to use. All right, now here's a little graphic that will really help you understand what in the world is happening with these percentages. All right, look with me at the left. I have 100 confidence intervals for a population, mu. I don't know mu, okay? Now, one thing I do know that if I averaged all of these confidence interval point estimates, okay, then it would be mu. So that's important. That's the central limit theorem. But when we're doing one of these problems, we don't have 100. We're only doing one. So if you notice here in this particular part, I have 100 of these intervals that I've made, and 70 out of 100 actually include the real population mean. So therefore, I am 70% sure. That is my confidence level. Now, let's go all the way over here to the right. Let's say that you really want to know what the average age of the Foothill College student is. So you want to have a 99% confidence level. Well, you can include the true population value, given all of our assumptions are true and the central limit theorem is true. You could do that. But notice how wide the confidence level is. And sometimes people will not buy into, that huge range of values, or sometimes it's practically meaningless. So what we do is we sort of just kind of pick a middle of the road, and we use a 95% confidence level. And notice that 95 out of the 100 levels include the population mean, and it's not too wide. That's the gist of inferential statistics right there in a nutshell. Can I get my mind around critical value? Yes, you can. If I want to be 95% sure, my critical value is going to be 1.96. Now, we already know this because the empirical rule says 2 standard deviations to the right and to the left include 95% of our data. See, that 2 is an estimate of the 1.96. We're going to call that in our work here the critical value. So the bigger the confidence, the bigger the critical value. So you may be asking, how do we get these numbers? Well, they're just z-scores in essence. So how can I understand this? Because it really is helpful here to know these numbers. So 90, 95, 98, 99, 1.645. You could think 45 doubled, that gives you 90. 1.96, you could think that's close to 2, or 96 is close to 95. 98, 2.326. You could think 2 and 3 make 8. And then 99, how do I know that? Well, I know it's close to 100, 2.5. Okay, then I got this 76. This is dumb, but 76 gas station, Phillips 76, 99% octane. Okay, really going places there. Maybe dumb, but that's the gist. If you want to know more, there's a good slide you could look at. When you're using your calculator, please be sure that you're looking for a z interval, okay? And then your answer will be displayed properly. Let's look at that problem again. We had 25 students. The mean was 30.4. Population standard deviation, construct a 95% confidence interval. Okay, notice I'm getting the facts out of the problem. Okay, so N, my estimate, sigma, confidence level, critical value. Here I'm laying it out exactly how, step by step, how to do the problem. I take my calculator, do 30.4 minus, and then I get 24.52. And then the other value would be 36.28. So the average age of the college are between those two age marks. All right, let's look at this problem here. Now here, I have some data, and I'm wanting to find out how many students I need to poll, how many students I need to survey. So let's say whatever it's your school, you want to find the age. Here's the information, 95% confidence level. They give all this information. Now, what I did here is I worked the problem out without memorizing a formula. You could just use the formula. It's going to be 1.96 the critical value times the standard deviation divided by the margin of error squared. I get 216.09. I always round up. I'd have to poll 217 students. Okay, please do not forget these problems, or the answers are given to you in your task list, and I've got a little solution guide for you if you want to see it. Okay, here's some information. Okay, so unit information. There's some information in that unit discussion that can help you. Quiz advice, know the 90 to 95% values. That will help you very much. Good luck.